Across the world, extreme weather is hitting places that aren't prepared for it. Blizzards in North America, floods in Europe, and snowstorms in places that rarely see snow. At first, these events seem unrelated, but scientists are starting to notice a pattern, and this could be even more of a warning than everyone was thinking. The weather pattern everyone is looking at is called the jet stream, and it controls much of Earth's weather. But recently, this system has started behaving differently, and the world is noticing. Most people have never seen the jet stream. You can't feel it, you can't smell it. It flows about 30,000 feet above your head, high above the clouds, above the plains, above almost everything you can see from the ground. But here's the thing, it controls nearly everything about your weather. Think of it as an invisible river of wind, a fast-moving belt of air that wraps around the entire northern hemisphere, steering storms, blocking heat waves, locking cold air near the poles where it belongs. For most of modern history, it followed patterns, predictable ones. Forecasters could read it like a map they'd memorized. But this February, meteorologists staring at their screens in the early morning hours noticed something that made them stop. The jet stream had started shifting, not gradually the way it normally does at the end of winter, but weeks ahead of schedule. And the question that kept them up all night was simple: why? In forecast offices from Denver to Berlin, they ran the models again and again. Not because they did not trust the data, but because weather scientists are trained to doubt, to cross-check, to make sure before they say something out loud. The models agreed, which almost never happens this far in advance. A senior forecaster with 30 years of winters behind him set down his coffee and said quietly, "We don't see this kind of shift this early. Not like this. Not unless something else is going on." Something else is going on. That phrase matters because what he was really saying is that the atmosphere itself is changing. And the jet stream, which is sensitive to those changes the way a compass needle is sensitive to a magnet, is responding. But here's what should really get your attention. The effects are not showing up in one place. They are showing up everywhere, simultaneously, in ways that seem completely disconnected until you understand what's driving them. Right now, the United States is experiencing what meteorologists are calling weather whiplash. This is a perfect example of a jet stream behaving in extremes. On the West Coast, California is being baked by its first heat wave of the year in March. Temperatures in the Bay Area are climbing into the 80s. Phoenix, Arizona is expected to see its earliest 100-degree day ever recorded, beating the previous record by more than 10 days. The National Weather Service is warning residents to prepare for unprecedented and potentially deadly March temperatures. A climate scientist at UC Agriculture and Natural Resources put it bluntly this week. "We are going to get to April 1st and see some very scary snowpack numbers essentially everywhere across the West." The Sierra Nevada snowpack, California's primary source of fresh water through summer, is already sitting at just 53% of average. It is melting fast. Meanwhile, on the other side of the same country, back-to-back winter storms are targeting millions across the Midwest and New England. More than 2 feet of snow is forecast across parts of Wisconsin and Michigan. Blizzard warnings are in effect. Wind gusts are hitting 75 miles per hour across the plains. Cities that saw temperatures in the 70s and 80s earlier this week are about to see highs in the 30s and 40s by next week. Same country, same week. Opposite extremes. This is not normal seasonal variation. This is the jet stream swinging hard, diving south out of Canada on one side, while a dome of high pressure traps heat in the west on the other. The wider those swings get, the more extreme both ends of the whiplash become. Now, cross the Atlantic. Britain is bracing for what forecasters are describing as a ferocious jet stream, driving low-pressure system after low-pressure system into the country. A Met Office meteorologist described it this week as a jet stream. so powerful it is reaching wind speeds of 220 miles per hour in the upper atmosphere, creating intense areas of low pressure that are battering the UK with gales, heavy rain, and snow in the Scottish Highlands. Temperatures in parts of northern Britain are expected to nosedive to -10 degrees Celsius. Ferry services are being cancelled. Wind gusts of over 70 miles per hour have already been recorded. And here is the detail that connects this directly back to what is happening in America. A Met Office meteorologist said on the record this week, the jet stream has been activated by severe storms over the US in recent days, and now it is active and heading our way. The storms in America and the storms in Britain are linked, driven by the same ribbon of wind. So why is this happening? What has actually changed? The jet stream owes its existence to contrast. Cold air near the poles, warm air near the equator. The sharper that temperature difference, the tighter and faster the jet stream flows, a taut cable of wind holding the seasons in their places. But the Arctic is warming at more than twice the global average rate. That is not a theory, it is a measurement, recorded by buoys and satellites and weather stations across decades. As the Arctic warms, the temperature contrast that powers the jet stream softens. The taut cable loosens, and a loose jet stream does not flow in a clean straight line from west to east. It meanders, it buckles, it dips far south, dragging Arctic air into places that were not ready for it. Then it arches far north, allowing tropical warmth to surge into places where winter should still be sitting quietly. Some scientists describe it like a river that begins to meander when the slope beneath it flattens. The river does not disappear. It just starts carving wilder curves. And those wilder curves are exactly what we are seeing right now. There is one more piece of this story that has not made as many headlines, and it might be the most significant of all. High above the weather, about 30 miles up in the stratosphere, something called the polar vortex has split. The polar vortex is a large circulation of cold air that normally sits locked over the North Pole through winter, kept in place by strong stratospheric winds. When it weakens or fractures, lobes of Arctic air break off and drift south, sometimes all the way to places like Texas, Florida, or the mid-Atlantic states. This winter, long-range experts are calling this split stronger than normal. It has already sent frigid Arctic air toward the northeast United States. Temperatures in parts of New Jersey are forecast to run 15 to 25 degrees below normal by mid-March. And a second push, another lobe splitting again, is predicted for late March into early April. The polar vortex and the jet stream are connected. When the stratosphere destabilizes, it sends a signal downward that disrupts the jet stream below. Scientists are still mapping exactly how these two systems interact, but the pattern is becoming harder to ignore. A disrupted stratosphere, a jet stream shifting early, weather whiplash across continents, record heat in winter, record cold in spring. Now, none of this announces itself when you step outside. The wind will not settle any arguments. It will not tell you who was right. But embedded in that wind, in its direction, its temperature, its persistence, is a record. A record of ocean warmth, of sea ice lost, of energy the atmosphere is holding onto in new ways. And the jet stream, faithful as a compass needle, is reading that record and responding to it. Meteorologists have watched this story unfold while also watching the backlash that comes whenever they try to describe it. The dismissals, the accusations of alarmism, the familiar charge that they keep changing their story. But what's happening right now across North America, across Britain, across the upper atmosphere, this is not a forecast. It's already here. The early shift has already happened. The heat wave is already breaking records. The blizzards are already falling. The polar vortex has already split. The jet stream is not waiting for consensus. A climate scientist said something this week that is worth sitting with. He said, "Winters like this one could very much be the norm in just a couple of decades. They will, in fact, be close to average on our current trajectory. Today's extraordinary is tomorrow's ordinary, and I think we're already living that. Today's extraordinary is tomorrow's ordinary. Somewhere tonight, in another overnight forecast office, a meteorologist is sipping lukewarm coffee and watching loops of color trace across a screen, tracking the same early bend in the jet stream, trying to turn a shifting river of wind into words the rest of us might actually hear. The atmosphere is not being dramatic, it's being physical. It's responding to what has changed, and those changes are no longer subtle. The jet stream has always told us something about the state of our planet. Right now, it's speaking louder than it has in a long time. The question is whether we're listening. If this video made you see the sky a little differently, hit subscribe. We're tracking this story as it keeps developing, and there is more coming. And drop a comment below. What strange or unusual weather have you been experiencing where you live? Because right now, you might just be part of this story.